Now, today we'll have to start the regression in the statistics regression. Okay. Now, regression is the prediction statistics. Is the prediction statistics, which is very much associated with the correlation. Associated with the correlation. And through regression, we can able to predict the score of the dependent variable on the basis of score of the independent variable. So that is the regression. I repeat it. So regression is the prediction statistics. There are so many types of statistics. So regression statistics, prediction statistics. Regression is under prediction statistics, which is linked to the correlation. And that predict the value of dependent variable, which is known as criterion. Dependent variable is now named as criterion. On the basis of independent variable or predictor. Independent variable is also named as predictor. So on the value of the predictor, we can able to predict the value of criterion. As this is the case of prediction, so it is under prediction statistics. It is the advance of the statistical analysis of correlation. It is the advanced mode of statistical analysis of correlation. And then, why? Why? Because in correlation, you can able to find out the direction of association and the strength of association. You know that chi-square test correlation is more strong, more powerful than chi-square. And from correlation, the most powerful is regression. Why? Why? If the question is coming that regression is more powerful than correlation, justify. Because in correlation, we only compute the strength of association, strength, that is minus 1.00 to plus 1.00. The value is within minimum minus 1.00 and maximum plus 1.0. So within that range, the correlation value should be confined. And that is known as the strength of association. Another one, the direction of association. That is either positive correlation or the negative correlation or the zero correlation. Okay. But in regression, we not only consider the direction of association, we not only consider the strength of association. Besides this, within the limited range of the independent variable, on the basis of the computation of the mean value of the independent variable, on the basis of the mean value of the independent variable and their standard error or standard deviation, we can able to find out the range of this independent variable. And within that range, the prediction of dependent variable can be computed. So in correlation, on the basis of a single independent value, the dependent variable is correlated either in positive or negative, and what is the strength of the correlation, we can able to determine it. But in regression, we not only determine their strength, we not only determine their direction, but also not only a single value of the independent variable, we can predict the dependent variable, but within the range within the range of the independent variable. Okay, the dependent score, the score of the dependent variable, that is the y, can be predicted. Can be predicted. And on the basis of such prediction, a regression equation line can be drawn. A regression equation line can be drawn. Such graphics presentation of this association of the dependent and independent variable cannot be done by correlation. Am I clear? So if the question is coming that regression is more powerful than correlation, what would be your answer? Number one is that through regression, we not only reflect the direction of association between the dependent and independent variable, we not only compute the strength of association between the dependent and independent variable, but also within the range of independent, within the range of the score of the independent variable, the specific score of the dependent variable can be predicted. And on the basis of such prediction of the scores, not scores, scores of the dependent variable, the regression equation line can be drawn, which is known as the graphics presentation of the regression. And such graphics presentation of correlation between dependent and independent variable cannot be drawn in correlation study. Okay? Now, such regression, therefore, you may say that regression is the translation about the translation, graphic translation of the relation between or among dependent variables and independent variables, which is focusing one of them as function of other, one of them as function of other, one of them as function of other. So regression can be defined as it is a graphic translation of the correlation between or among the variables, between or among the variables. If one independent and one dependent, then between her. But if more than one independent and one dependent, then among the variables. The expression focusing one of them as a function of the other. Okay?
Focusing.
And the most important point of regression is that this regression holds good only. That means this prediction is performed only, that I have already mentioned, the first definition, only within the limited range of scores of the variables, not beyond that range. As for example, suppose the mean value of independent variable is 90. Am I clear? And if this deviation, standard deviation is suppose 15, 15, then the range of the independent variable score is 90 plus minus 15. 90 plus minus 15. That means 19 plus 15, that is 105, or 19 minus 15, that is 75. So within 75 to 105, within this range, mind that, we can predict the defined score of the dependent variable. But not beyond that. That means not beyond 105 or not below 75. Am I clear? So this regression, that prediction of the dependent score can be performed, mind that, within the limited score, limited range of the score of independent variable. Beyond that score, beyond that limit, we are unable to predict the dependent score of the dependent variable. Okay, so that is all about the regression. Now, next point that we like to focus on the types of regression. Types of regression. Now, on the basis of the number of independent variables, you know independent variable. What is independent variable, or that is known as the key predictor. Independent variable, the predictor. Independent variable, that means the variable that is totally under the control of investigator. Totally under the investigator can able to control its dose, control its time of application, and control the frequency of application and others. So when the variable is purely, solely under the control of investigator, then it is referred as independent variable. And later on, we like to divide. This is the basic point of independent variable, though the independent variable is also divided into two types. One is the fixed control variable, and other is fixed, that is the control, under control, and another is the random independent variable. Fixed control, that means these are solely under the control of investigator, and some are randomly controlled, Okay, that means they are not under pure control, under total control of investigator. So that is the randomly controlled independent variable. Okay, randomly controlled independent variable. What is randomly controlled independent variable? Like the environmental temperature. I am unable to control the environmental temperature. Though the environmental temperature can able to control the dependent variable like the thyroxine secretion. You know that summer season, the thyroxine secretion is less. And in the winter season, the thyroxine secretion is high. So the environmental temperature, that is the independent variable, mind that. But it is not under the control of investigator. So this is known as the randomly controlled independent variable. So independent variable is not always under the control of investigator. On the basis of the mode of controlling capacity of the investigator, it may be divided into two types. One is known as the fixed control variable, independent variable, and other is randomly controlled independent variable. So what's the one? So types of regression, that means on the basis of the number of independent variables, how many independent variables are acting on dependent variable. How many independent variables or variables are acting on dependent variable. On that basis, regression is of two types. One is known as the simple regression, and other one is multiple regression. Simple regression, and other one is multiple regression. Am I clear? What is simple regression? A simple regression, that means when the scores of the dependent variable or criterion are predicted from the given score of single independent variable. So when the scores of the dependent variable is predicted under the influence of a single independent variable. So number of independent variable is 1. So under the presence of single independent variable, when we predict the score of the dependent variable, then this is known as the simple regression. Am I clear? Simple, that means single independent variable. Okay? So under the influence of single independent variable, when we predict the score of the dependent variable, then it is known as simple regression. Am I clear? Now, what is, as for example, you may say that on the basis of the insulin injection, at the different dose, you can able to predict the blood glucose. So insulin injection, insulin is a single independent variable, and the blood glucose is a dependent variable. On the basis of the variation of the dose of the insulin, the blood glucose level will be changed. And on the basis of such correlation, we can able to predict a regression equation line. Okay. So the blood glucose, the dependent variable score is predicted on the basis of the single independent variable, that is the blood, that is the insulin. So it is the example of simple regression. Okay. Now, what is multiple regression? Multiple regression, that means the score of the dependent variable, is predicted under the presence of, under the exposure of, under the treatment of more than one independent variable. So when two or more than two independent variables are acting to change the score of the dependent variable. Am I clear? And if the score of the dependent variable is predicted on such score of the independent variables, because two or more than two independent variables are acting, and that is the multiple regression. As for example, you know that our body surface area, BSA, body surface area, it is a dependent variable. It is controlled by two independent variables, that is the height and weight. Height of the individual and weight of the body weight of the individual. So height and weight of the individual are independent variable, and the body surface area is a dependent variable. So in that case, the body surface area can be predicted on the basis of the height and weight, So it is an example of multiple regression. So is it clear? Simple regression and multiple regression. Okay. Now, next classification on the basis of the nature of graphics of regression. Nature of graphics of the regression. It is also divided. One is known as the linear regression, and other one is the non-linear regression. Linear regression, and other one is the non-linear regression. What is the linear regression? Now, in the x-axis, we represent the independent variable. Mind that. In the x-axis, the horizontal axis, we represent the independent variable. And the vertical axis, that is the y-axis, we represent the dependent variable. Okay? So when we put the value of the independent variable along the x-axis and the value of the dependent variable along the y-axis, am I clear? And putting the scores of the independent and dependent variable in a graph paper, if it gives a upward straight line or it gives a downward straight line, then it is known as linear regression. Okay? If there is a positive correlation, then it gives an upward straight line. If there is a negative correlation, then it gives a downward straight line. Am I clear? At a specific angle, upward or downward. So putting the value of the independent variables along the x-axis and the scores of the dependent variable along the y-axis, if we got a upward straight line or downward straight line, then it is called linear regression. Okay? As for example, if we increase the dose of the insulin gradually, then the blood glucose level will be gradually decreased. And so it gives a downward straight line. In contrast, if we increase the glucagon level, then the blood glucose level will be gradually increased. It will give a upward straight line. Okay? So both are linear regression. Now, what is non-linear regression? Non-linear regression. Now, putting the value of the independent variable along the x-axis and representing the value of the dependent variable in the y-axis, if such straight line is not noted, mind that. If curvilinear distribution, curvilinear distribution is developed. Like it may be hyperbolic in nature, it may be elliptical in nature. Okay, then it is known as the curvilinear regression. As for example, if we increase the substrate concentration and presenting it in along the x-axis, and the turnover rate from substrate to product, or you may say that is the velocity of enzyme kinetics, velocity of this turnover, that is the enzyme kinetics along the y-axis. Then, after a certain time, the curve will not perform a linear relation. Okay? And it forms a curvilinear distribution. Okay? It may be hyperbolic in nature. So, this hyperbolic or elliptical is referred as non-linear regression. So, on the basis of the nature of graphics, it is divided into two types. One is linear and the non-linear. Next one, there is the model of regression. Model of regression, there are actually three models of regression. Model 1, Model 2, and Model 3 regression. Model 1 regression, Model 2 regression, and Model 3 regression. What is Model 1 regression? Now, in this regression, the dependent variable, that is the y, is predicted on the basis of the value of the independent variable, which is fixed statement variable. I have already mentioned the independent variable is of two types. One is the fixed statement, and another one is known as the randomized statement, randomly controlled. So fixed statement. So when the independent variable is precisely controlled, deliberately controlled, and predetermined way of control, then this is known as the fixed treatment variable. Independent variable known as the fixed treatment variable. Fixed treatment variable fulfill the criteria, that is, it is deliberately modulated or manipulated by the investigator. It is precisely manipulated by the investigator. It is manipulated by predetermined nature, predetermined way of the investigator. Then these are known as the fixed treatment variable. This independent variable is known as the fixed treatment variable. So when we like to predict the score of the dependent variable on the basis of the value of the fixed treatment variable types of independent variable, fixed treatment type of independent variable. What is fixed treatment? That I have already mentioned. Then this is known as Model 1 regression. This is known as Model 1 regression. Okay. Now this Model 1 regression is again divided into two types. It is known as simple Model 1 regression, and another one is known as the multiple Model 1 regression. Simple Model 1 regression and multiple Model 1 regression. Simple, I have already mentioned that when the independent variable, which is fixed treatment variable, is 1. When single or one fixed treatment independent variable is exposed on that dependent variable, and on that basis the score of the dependent variable is predicted, then it is known as the simple Model 1 regression. Simple Model 1 regression. What is the multiple Model 1 regression? Model 1, that means it should be fixed treatment variable. So what is multiple, that means more than one. So when two or more than two independent variables, which are fixed treatment variables, are applied on dependent variable, and on that basis we can able to predict the value of the dependent variable, then this is known as the multiple model 1 regression. I repeat it. Model 1 means prediction of dependent variable on the basis of fixed treatment independent variable. So in model 1, always the independent variable should be fixed treatment variable. Fixed treatment means that independent variable should be deliberately manipulated, precisely manipulated, predeterminedly manipulated, or modulated, or changed by the investigator. That means totally under the control of investigator, totally under the grip of investigator. Okay? So if such independent variable number is 1, and we predict the value of the dependent variable, then it is known as simple model 1 regression. But when such fixed treatment independent variable number is 2 or more than 2, and in that case we predict the value of the dependent variable, then it is known as multiple model 1 regression. Am I clear? Now, what is model 2 regression? Model 2 regression. Now, model 2 regression means model 2 regression. What is model 2 regression? Now, model 2 regression, that means here the independent variable or variable are not under control of investigator, are not under the control of investigator. Okay? And these are known as randomly controlled independent variables, or these are known as classification variables. Mind that. So they are named as randomly controlled independent variables or classification variables. So when we like to predict the dependent variable, predict the score of the dependent variable, after the application of one or more than one independent variables, which are classification variables or randomly controlled variables, then this is known as the model 2 regression. So model 2 always deals about independent variables, variable or variables, which are classification variables or randomly controlled variables. That means these variables are not controlled by the investigator. Then this is the model 2. So model 2 is again divided into 2 types. One is known as there's a simple model 2 regression, and another is multiple model 2 regression. Simple model 2 regression, that means when there is a single independent variable, but its nature is classification variable. It is randomly controlled variable, which is not deliberately, precisely, and predetermined way under the control of investigator. As for example, I've already mentioned that if you like to study the level of thyroxine in defined environmental temperature, or defined, you may say that different, that is different month of the year, different seasons, like summer season, winter season, rainy season, etc. So here the season is the independent variable that can influence the thyroxine level. But the seasonal change, the seasonal temperature, this is not controlled by investigator. So this independent variable is classification variable. This is randomly controlled variable. Okay. So when we consider single independent variable, which is classification variable or which is randomly controlled variable, and under its direction, if we predict the value of dependent variable, then it is known as single model 2 regression. Okay. Now, what is multiple model 2 regression? Now, multiple model 2 means, I have already mentioned, this is classification. So when 2 or more than 2 independent variables are applied, and both the independent variables or more than two or all of the independent variables are classification variables, or these are randomly controlled variables. And in that situation, we predict the value of the dependent variable. We predict the value of dependent variable. Then it is known as what? It is the model to multiple model to regression. Am I clear? And for example, on the basis of the seasonal variation, as well as on the basis of the gender variation, gender, male and female, gender variation, we like to predict the value of the thyroxine. So here, independent variables are two. Independent variables are two in number. One is known as the seasonal variation and another was the gender variation. And both these independent variables, that is the seasonal variation as well as the gender variation, are not under the control of investigator. Okay, because I am unable to change the rainy season to summer season, summer into rainy, as well as we are unable to control, change the male into female and female into male. So gender as well as the seasonal variation, both are beyond the control of the. And under this situation, if we like to predict the thyroxine level, plasma thyroxine, then it is under the category of multiple model to regression. Okay? Now, what is model to regression? The model to regression is referred as mixed regression, mixed model regression. Like, the model 3 regression is known as mixed model regression. Mixed model regression, that means here more than two or more than two. So it is never single, it is always multiple. So model 3 regression is always multiple model 3 regression. There is no chance, there is no option of single model 3 regression. Single model 3 regression. Why? Because number of independent variables which are applied here, at least two or more than two. At least two or more than two. So as the number of independent variables is at least two, so there is no option for single model 3 regression. Okay, so it is always multiple model 3 regression. In NET, this question is set in frequent time, that model 3 regression is single, multiple, both. So it is always, or only multiple, it is always multiple model 3 regression. Model 3 regression is always multiple model 3 regression, not single model 3 regression. So in multiple model 3 regression, at least two independent variables or more than two independent variables are adopted or are applied. And these independent variables are mixed in nature. If the number of independent variables are two, then one should be control treatment variable and other should be randomly controlled variable or classification variable. Similarly, if the independent variables number is 3, then either 1 or 2 would be randomly controlled, and rest, if 2 is randomly controlled, then 1 would be fixed control. And if 1 is randomly controlled, then 2 would be fixed control. Okay. So mixed independent variable, that is randomly controlled variable, and the fixed treatment variables are adopted here. And in such situation, we like to predict the value of the dependent variable. And it is known the model 3 regression. Model 3 regression. Am I clear? And for example, if we like to study the thyroxine secretion, plasma thyroxine level under the variation of season as well as under the application of or injection of TSH, thyroid stimulating hormone. So in this case, there are two independent variables, TSH, thyroid stimulating hormone is one independent variable and seasonal variation is one. And seasonal variation is key. There is the classification variable or randomly controlled variable, and the TSH is, there is a control treatment variable. So one is control, other one is classification. And in presence of such two different types of independent variable, we like to predict the value of the thyroxine, that is the dependent variable. So it is a mixed model regression or model 3 regression. Okay. Now in regression, we mainly compute the regression equation of independent variable, that is y on x. So the regression equation of y on x, mind the regression equation of y on x, that is performed by a formula, that is predicted y, that is y hat, is equal to ayx plus byx into x. X, that is the independent variable, and y hat is the predicted dependent variable. So y hat, we like to predict the value of the dependent variable. So y hat equal to ayx plus byx into x. Now, how you compute the byx? You also, the data is also provided on the dependent variables and independent variables. Dependent variables is x. You arrange the score of the independent variable in the x, and you also arrange the score of the dependent variable dependent in the y column, in the y score. Okay. So the byx is computed by the formula, that is n small n, that is the number of subjects considered in such study, n into summation xy minus summation x into summation y divided by n summation x square minus of summation x whole square. So using this formula, so first you use the column. I also sent it through photograph mode. That formula I like to send on after completion of this lecture. I also send this formula. So you also arrange the score of the independent variable under x column, and then you arrange another score of the dependent variable in the y column. Okay. Then you also arrange the x square value of each x, of each independent variable score, and then you add it. Then the summation x square you can able to collect it. Okay. So summation x square. Then you also, another column, you also multiply x into y, that is xy, and by the addition you will give the summation xy. So on this arrangement of this column, you will get the summation of xy, summation x, summation y, and the summation x square and summation x whole square. So by using this value, you can able to determine the byx. Now what is ayx? Ayx, that is the y hat minus byx into x. Y hat, that is the predicted value of y, that is the predicted value of the dependent variable. Okay. Suppose, for example, 1 minute moment, that for an example, I give an regression equation. Suppose y hat is equal to 112 plus 1.5x. 1.5x. And in this regression equation, the x bar, that is the mean value of the independent variable, is 90, and the standard deviation is, suppose, 28. Then the range of this score, x score, would be 90 plus 28 to 90 minus 28. 90 plus 28, that is 118, and 90 minus 28, that is 62. So from the range of 62 to 118, you can able to consider any value of the x. And putting the value of the x in the above regression equation, you can able to predict the dependent variable, that is a y hat. So from the score of 62 to 118, suppose you consider the value 95, x is 95, because it is within the limit of 118 to 62. So if you consider